Once again, take out your notebook because we're continuing our notes. I know last time when we started talking about transformations, I also covered translations, and I told you guys that Stacy Jordan. Last time I see you guys talk, if you guys I see talk to you guys again during class, you guys are moving. All right. So once again, last time I stopped at translation, and I said the notes were a little lengthy, and I was going to continue later. So let's continue with our notes. Let me skip everything that we saw. That was on translation. That's where you guys were. That's where we stopped. Do me a favor. Don't start a new note. Just continue where you left off. Okay, we'll continue with the notes. We're not starting something new. So this is the last thing you guys should have on when we cover translations. So now let's move into what we call reflections. Do me a favor, copy that out, and then I'll explain this in a minute, what the mumbo jumbo says. So reflections, a reflection is an isometry, which means that per image and image are congruent that can be described as a flip. To perform a geometry reflection, a line of reflection is needed, and the resulting orientation of the two figures are opposite. I'll give you guys time to write it down. A reflection is an isometry, which means that per image and image are congruent that can be described as a flip. To perform a geometry reflection, a line of reflection is needed, and the resulting orientation of two figures are opposite. Just pass out the worksheet. We're not quite done with the notes yet, but just wanted to pass it out already. I'm about to show you guys some pictures. I'm not going to ask you to copy the pictures. I'm just going to use it to explain myself. Right, so the pictures you guys are about to see don't have to copy them out. So in isometry, what it is you guys see in the top I have a triangle. It gets reflected on the other side. It looks like a mirror line. Imagine it. That's what isometry means. So, but one thing on the line of reflection, my line of reflection here is the x-axis. The important thing on reflection is, if you look at my point A, the space on one side of the mirror line is the same distance on the other side. Looking at my C, the space on one side of the mirror line is the same distance as the other side. Kind of like when we have a mirror, if you're close to the mirror, it looks like you're really close on the other side. But if you're far from the mirror, it looks like you're really far on the other side. Right? The distance remains the same. So if you notice my B and my B prime, they're the same distance from the line of reflection. Sometimes the line of reflection could be the x-axis, the y-axis, but sometimes a line of reflection could be a little So the way we count the space there is not up or down. Since my line is diagonal, I'll count my spaces diagonal as well. Look at my B, is a certain distance on one side of the mirror, it should be the same distance on the other side for B prime. So for mirror, we count the space. Now, let me add a few special cases, and we're going to add those on our notes. So this is the line, this line that I have here is the y-axis. So we're going to come and use a rule for that. You guys see I have in black, I have my pre-image. In red, I have my image. But I can follow each point, but I'm going to follow B for this case. Look at the coordinates of B are negative 2, 6. Look at the coordinates of B prime are 2, 6. All right, when I copy from one side to the other. So do me a favor and copy the next group. Reflection across the y-axis. xy becomes negative xy. So reflection across the y-axis, xy becomes negative xy. Matter of fact, I'm also going to write it on the board because we're going to use it for the next couple of weeks. If you notice, I already have translation, which is what we used last week. So I have a few for reflection and a few for rotation. And what I mean with the negative x, I don't mean make it negative, I mean change the sign. You notice how at the beginning x was negative 2, we converted to positive 2, right? We switched the sign. So another rule that we have that's special is the x-axis. So do me a favor, I'm not going to complete it yet, because you guys will help me out on this one. So let's start writing this rule. Reflection across the x-axis, xy becomes, once again on this one, you guys will help me out. So reflection across the x-axis, and once again I have the coordinates for B, and I have the coordinates for B prime. xy becomes what? X negative y. Good. And we just switched the sign on the y, basically. Another rule that we have is the line y equals x. You guys learned how to graph that line in algebra. So that's that line in green, that's the line y equals x. So let's start writing this out. Reflection across y equals x, xy becomes, and once again, this one you guys will help me out. So do me a favor, write the rule out. Reflection across y equals x, xy becomes
Negative y, negative x.
not negative y, negative x, yx. Because we're not switching signs, so that's why not negative. They just swap. So xy becomes yx. Swap. Okay. The other special rule is the line y equals negative x. You guys see my mirror line there? You guys can count the spaces if you wish. They're the same distance. But the rule for this one, reflection across y equals negative x, xy becomes, once again, copy this and help me finish it. Xy becomes what? Negative y, negative x. Good. I'll complete it here on the board. I'm going to leave the 3 for rotations for tomorrow. I'll do the rotations tomorrow. But we have 4 special rules for reflection today. Some cases, it's not a special case all the time. Some cases we might see something like this. And it's neither of those. How do we call this line? It's a vertical line, but do you remember the name of it? You remember the y-axis is right here. So well, it will be a line, but on the coordinate plane, how do you guys know how this line called? Well, it is a straight line. Well, it's a line, but how is it called? Remember how this one here to the left of it This one we call the y-axis, right? How do we call this in green? Help you guys a little. One name for the y-axis, this line is also called the x equals 0 line. The y-axis. So how is this green line called? X equals 2, nice. X equals 2. That's the x equals 2 line. Because it's x equals something. If you notice, the only coordinates that change were my x values. X. Right? If I had y equals something, the only coordinates that would change would be the y. But an interesting part though, if you notice in my x values, 6 and negative 2, what's the midpoint? Remember for midpoint, add them up and divide it by 2. What's the midpoint of 6 and negative 2? Not 3. Remember, add them and divide it by 2. What was it? 2. And that's how we get our x equals 2. So if I give you guys the 2 points, the 2 coordinates, you guys notice that the x changes. You're now messing with the x equals something line. For me to find out what x equals something, x equals what? Find the midpoint of the x's. At the same time, I could give you guys the mirror line. I could give you guys the per image and ask you to find the image. But I know when we were dealing with midpoints, there were cases where I gave you guys an endpoint, a midpoint, and I asked you guys for the other endpoint, and we worked with those. And that's something we're going to work with later on today. So let's take a look at our worksheet. Let's pause our notes for right now. We'll come back to them tomorrow. So let's take a look at our worksheet. Reflection across y equals 1. So first of all, I need to remember how the y equals 1 looked like. And that's my y equals 1 line. Right? I need to remember how the y equals 1 line looks like, and that is it. Remember, the x-axis is called y equals 0 as well, so we know what y equals 1 looks like. Look at my h is one space below the mirror, so I'm going to put my h prime one space on the other side. The distance on one side of the mirror should be the same on the other side. Look at my point I is 4 spaces from the mirror, so it should be 4 spaces on the other side as well. And I'm going to put it right there. Looking at my G, from the mirror, it's 4 spaces, so let me count 4 spaces on the other side. Once again, from looking at my G again, I count my spaces from G to the mirror line. Ignore the axis, count it to the mirror line. I count my spaces 1, 2, 3, 4. So my G prime should be 4 on the other side. Remember, the distance from one side of the mirror should be the distance on the other side. I see some faces. Okay. Do you guys have any questions so far?
How do you know when it's a little line? How do you know if it's a 1?
Because it was labeled here y equals 1.
Oh, okay.
So that's how I know which one is my mirror line. Now, I'm just going to connect my points. So 2 things we need to do. First of all, identify the mirror line. Right? They call it y equals 1. So identify the mirror line. That's one thing. The other thing, count your spaces on one side of the mirror line, and it should become on the other side. One thing to keep in mind though, if my mirror line does not cross my per image, my 2 images, my image and my per image will not overlap. But if my mirror line happens to go through my image, my 2 images will overlap. So they will be overlapping if the mirror line goes through. As an example, let's take a look at question number 4. Take a look at example number 4. the mirror line is the line x equals 1. So we have to draw our mirror line. That's my line, x equals 1. See how my mirror goes through my free image? I'm pretty sure that image, whatever get reflected, in this one, they will overlap. They will be overlapping. I notice that in this case, there's 3 points on the left of the mirror, which obviously I will bring to the right. There's 1 point on the right, which obviously I will bring to the left. So looking at my W first, it's 2 points from the mirror. I'm going to count 2 spaces from the other side, and that's my W prime. My X prime is here. My Y prime is here. And my Z prime is here. The way I count each of my points, I counted the distance from the mirror line, and it needed to be the same distance on the other side. Like the Z is 2 spaces from the mirror, Z prime is 2 spaces on the other side. Then just connect your points. Once again, my pictures overlap, but I was expecting that. Okay. Any questions on the first point? No? Go with it. Number 3? Sure. Let's take a look at number 3. My x-axis, so I need to identify my mirror, which is that one. My figure is on the top, so I'm going to bring it to the bottom. But count spaces. G is 2 spaces from the mirror. G prime should be 2 spaces on the other side. I prime should be here. And H prime should be here. And once again, I was counting spaces. Yeah, my drawings tend to be sometimes a little bit off, but do keep in mind that I write on the air. You guys have some support from the desk. I literally write on the air. So I don't draw lines ever. They look all perfect. But the idea we get it, right? Okay, let's move on. Let's take a look at question number 5. I know my screen, I can tell the difference between black and blue. I can look at the difference of colors. Yours are only black, but you can tell the difference on the right. Right? The pre-image only has the letters. The image, after the transformation, has the primes. So you know which one came first, which one came later. It says, write a rule to describe each transformation. Today we're dealing with reflection only. So I'm pretty sure this will be reflection across, because we're dealing with reflection for today, y-axis. If you can see that a mirror will draw it, if you cannot find it, let's say we couldn't find it, we couldn't tell the y-axis, one thing you can do, find 2 points on the mirror line, and that way you can find it. Look at your C and C prime, find the midpoint of it, and that is 1 point on the mirror line. So once again, if I look at my C prime, the point in the middle, the midpoint, that is 1 point on the mirror line. For another point, let me look at my B and my B prime. That gives me another point in the middle. Connect your points, and that is your mirror. Like that, if you cannot see your mirror line, find 2 points on it. And the way you can find it, like I said, look at the C and the C prime. The midpoint is 1 point on the line. I did the same thing with my B and my B prime. We could have done the same thing with A and A prime. Right? Find 2 points on the mirror line, connect them, and that gives you your mirror line. The hardest part will be knowing how to name it. Like if it is x equals 1, y equals 1, like that would be the hardest part. Any questions from 5 through 8? Yes. Number 6? Alright, looking at number 6, we're dealing with reflection, so I'm pretty sure this is reflection across. Now I need to find the mirror. If I look at my W and my W prime, the point in the middle is that. If I look at my V and my V prime, which is the same point, the midpoint should be right on the same stuff again. Connect my 2 points. How do we call that line? Y-axis. If instead of y-axis you guys call it x equals 0, it's okay. It's the same thing. But y-axis or x equals 0 is the same line. Right, any more questions up until 8? 7? Alright, let's take 8. Alright, let's take a look at 8. We're dealing with reflection, so I'm pretty sure this is reflection across. Okay, now we need to find the mirror line. If I look at my T and my T prime, the point in the middle is that. If I look at my U and my U prime, the point in the middle is that. Well, I could do the same for my S and my S prime, but 2 points is enough. Those 2 points give me this line. How is that line called? X equals negative 2. Remember that y-axis is x equals 0, so that should be x equals negative 2. Alright, so I'll let you guys finish number 7 from that group. Let me take a look at number 9. Find the coordinates of the vertices of each figure after the given transformation. So for this case, if you notice, I'm dealing with y equals something. My reflection is y equals something. So that means I'm not messing around with the x. So one thing I could do, I will just come and say, from my b prime, my x value will be 0. For my c prime, my x value will be 3. And for my d prime, my x value will be 4. Once again, I'm not messing with the x, I'm messing with the y only. Because my line was y equals something. So if my line was x equals something, I will be messing with the x. Okay, so now my question is, from negative 3, looking at the y, from negative 3, what do you do to negative 3 to make it negative 1? Add 2. So add 2 to this point. How much is negative 1 plus 2? 1. So that's my y, my point and my y. Remember back in the days when we did endpoint and midpoint, I used to ask you guys, what do you do to the endpoint to get to the midpoint? Now, once you find the rule, do it to the midpoint again. Remember, the mirror line is the midpoint. Alright, let's take a look at C. What do you do to negative 1 to make it negative 1? Add 0. So add 0 to your midpoint, and you get negative 1. Now looking at the D, what do you do to negative 5 to make it negative 1? Add 4. So add 4 to this point. How much is negative 1 plus 4? 3. Once again, our reflection, the reflection line is the midpoint. Right? Any questions up until 12? Faith says yes. 11? Alright, let's take a look at 11. For my u prime, I know my x value is 0, because once again I'm messing with the y. My t prime, my x value is 1. My s prime, my x value is 3. And my r prime, my x value is 3. Once again, I'm messing with the y's again. So leave the x alone. Alright, looking at my u, what do you do to negative 2 to convert it into negative 1? Add 1. So add 1 to the midpoint. What do you guys get? 0. And remember, my midpoint is this, right? That's what I call midpoint. All right, looking at t's, what do you do to 0 to make it negative 1? Subtract 1 or add a negative 1. Okay, so subtract 1. Now do it to the midpoint again, and what do you get? Negative 2. Okay, good. For my s, what do you do to 0 to make it negative 1? Subtract 1 from the midpoint, and what do you guys get? Negative 2. For my r, what do you do to negative 3 to convert it into negative 1? Add 2, so add 2 to the midpoint, and what do you get? 1. For today's worksheet, there will be many of these not special cases. And what I mean with special cases, the ones that we wrote on the board, the ones we follow the rules, like the y-axis, the x-axis, the y equals x, the y equals negative x, those are the special cases. So for today's worksheet, I'm not including that many special cases. But tomorrow, we're going to move into rotation, which is something more new. On Wednesday, I want to practice reflection and rotation only. So today, tomorrow, we're going to review it on Wednesday. But on Thursday, I'm going to review all three. When I mean all three, is reflection, rotation, and translation from last week. So like I said, today, tomorrow is new. Wednesday's a review of today only, but on Thursday, it's a review of all three. And next week, I add dilation to it. So there's 4 transformations. And there's a point where we're going to have a worksheet with all 4 mixed. All right, so any questions up until 12? Lastly, let me take a look at number 13. Says write a rule to describe each transformation. I'm pretty sure we're dealing with reflections today. So this is going to be reflection across from something. Let me compare my e's. Which is a number that I'm not messing with? The x is the same. So that means my reflection will be y equals something. And you notice the x values is the same, so we're not messing with the x. We're messing with the y. And the way we're going to find what value of y, look at your numbers of y, negative 5 and 5, and give me the midpoint. Which is what? 0. So reflection across y equals 0. If some of you guys write this as reflection across x-axis, it's the same thing. Right? The x-axis y equals 0 line is the same thing. So either or, I'll consider okay. Once again, look for the letter that is changing. In our case, was y. For you to find the value of y, find the midpoint of the y. And you could, like I tried it with the e, but we could have done it with any other point. All right. Any questions up until the end? Okay. Another one? It's 14, okay? All right. Looking at number 14. Since we're dealing with reflections today, let me start with this reflection across, because I know it's going to have to be a reflection, because that's what we're doing with today. I'm going to look at my f and my f prime, and I'm going to compare those. Which value is the one that changes, the x or the y value? The x, so this is going to be x equals something, because that's the one that changes. And then one of them is negative 3, the other one is positive 5. What's the midpoint of those two? Not positive 2. Remember, for you to find the midpoints, add them and then divide it by 2. 1. Remember, add the two values. 5 minus 3 divided by 2. Remember, add the values and divide it by 2. Does that make sense? Remember, active value divided by 2. So that's why we get x equals 1. Alright, are we good? Everybody get any questions?
You always divide by 2?
Yes. For the midpoint, yes.
So it's like a formula.
Yeah, the formula we had was x1 plus x2 over 2 and y1 plus y2. Remember? Alright, no questions?